Hello, ngHouston. So tonight we are here with Keith Stewart, who is actually in person at Improving, and I am off location. So tonight we are talking about
unit testing.
Unit testing, yay! So it's gonna be really awesome, and let's just get right into it. By the way, I'm Bonnie Brennan, your host for tonight. If you couldn't tell, I look just like her. Okay, let's get this started.
Thanks a lot, Bonnie. All right, thanks everyone for joining. We got a few people here, and I think we got a few people online as well. So let me go ahead and share my screen here. Oops. All right, you see my screen, Sam?
Yes.
All right. All right. Yeah, again, thanks everyone for joining. I'm Keith Stewart, and I am a front-end Angular developer for a company called CollabNet, working mostly in the DevOps realm, but I am the lead UI developer for DevOps. Today we are going to be talking about unit testing in Angular. And if anyone's interested, got my Twitter handle up there and a link to the slides. They'll stay up there after this if you want to refer back. All right, so we got a bit of a list of things that we're going to cover here. This is by no means an in-depth look at unit testing. There's plenty of very complex areas of unit testing that we could dive into, but I think I'm going to leave that for another talk. So we'll start off with going over some of the basics and talk about some of the tools and technologies that are typically used in Angular testing, and zero in on the ones that we'll be working with today. We'll briefly go over Tom, who's here with us today, and I were talking about mocks earlier, and this is an area where I think there's a bit of confusion and a lot of different definitions of what a mock is and how it relates to stubs and things like that. So we'll talk about that a little bit, and then there's an application that a number of tests for. We'll go through some example tests that are in there, and time permitting, I think we can get to this. I'm hoping that we're going to be able to actually develop a new feature on that application using test-driven development. All right. Is everyone here at least loosely familiar with Angular? Yeah. And do you write unit tests? Yeah. Got a little bit of yes, a little bit of no. Okay. Okay. Yeah. Angular is an area from the very first iteration of Angular, AngularJS. It was developed with unit testing in mind. But that being said, it has, especially with AngularJS, could be a little difficult to test. With Angular, just Angular, Angular 2, Angular 4, 5, whatever you want to call it these days, it's gotten, in my opinion, quite a bit easier. So why should we test? There was a good quote from Igor Minar at Angular Mix this past week, where he said, automated testing is an enabler. It's the thing that allows us to iterate on our code, bring more features, more risky refactorings, make aggressive performance optimizations, all while knowing that all of our features, all the features we've built already, still work. This is key. Tests, it's an easy thing to skip by, but tests offer a lot of value applications. It makes it so much easier. And refactoring, I think, is a huge one that he hits on there. We refactor our code all the time, moving things around, changing APIs. A lot of times, having tests in place really helps you to easily find and fix all of the things that you're breaking when you're doing those refactorings. So some of the primary benefits of testing applications are improved code quality. That's probably the obvious one. Reduced overall cost of development. This is one that I think is not as well understood. A lot of folks think that skipping tests while you're developing something really saves you time. And it kind of does in the beginning. You're able to get more code out quickly. But once you get a little further along, the thing that we spend the most time on as developers is really. So if you spend a little bit of extra time in the beginning writing these unit tests, it can honestly save you a tremendous amount of time in the future. I meant to get a graph in here about this. The talk that Igor gave at Angular Mix, he had a graph representing this that I thought was really good, and it showed that in the beginning, like I was talking about, you will spend a little bit more time up front, not that much more though, and then all of a sudden, the amount of time that you save from not having as many bugs in your code, it makes for a tremendous time savings. Better documentation of your code. This is one of my favorite things about testing, honestly. It's documentation. And it's not something that I think a lot of folks think about, but when you are writing a function, we'll see some of this in a little bit. When you're writing a function and you're writing tests against it, typically the way that you write those tests is by writing tests for all of the requirements that function needs to actually complete. So therefore, if you write tests against that function, even if it's a rather complex function and maybe hard to look at that code and get a good feel for what it's doing, someone should be able to look at the tests and actually really quickly see exactly what that function is meant to do. And increase confidence in your refactoring. So that's something I was hitting on earlier. Yeah, that's a big benefit there. All right, so there's a number of different types of tests. We're not going over all of these today, but I thought it's still worth pointing out. We're going to be focusing on unit tests, but there's also functional tests and end-to-end tests. Functional and end-to-end tests world tend to be kind of intertwined. You really don't hear that much about functional tests, but really functional tests, we'll get into a definition on that in a moment. So unit tests. Unit testing is a software testing method by which individual units of source code are tested to determine whether they are fit for use. So anyone know what a unit is when it comes to unit testing? Any guesses? A unit, in its very basic form, it's the smallest thing that you can get in an application. It's one bit of functionality. So a unit test isn't necessarily, it's not an entire function, it's not an entire object, it's one feature, not even a feature, it's smaller than that. It's one requirement for that function, one thing it's supposed to accomplish. All right, I started getting into functional testing a moment ago. So functional testing is what most people do when they're writing protractor tests. Anyone use protractor? Right? Okay. Well, protractor is another key technology in testing Angular applications. It's a a technology that uses Selenium WebDriver for writing what most people call end-to-end tests. The difference between a functional test and an end-to-end test is that a functional test is really just taking one particular feature from the UI and testing it in the browser from the user's perspective, okay? So with Protractor, what it does is it'll bring up a browser, it'll complete some tasks. Maybe this is login. So it'll bring up the browser, take you to the authentication page, enter in a username and password, hit the button. That's the end of a functional test. Whereas end-to-end tests is a methodology used to test whether the flow of an application is performing as designed from start to finish. Okay, there's the key distinction between functional testing and end-to-end testing. Really, end-to-end testing, to me, like I kind of referred to earlier, I think a lot of these terms, there's differing definitions around, but to me, end-to-end testing is a grouping of a bunch of functional tests that take you from the beginning of what your application does to the end. Maybe you have a bunch of integration points. So not only are you logging in to the system with that first functional test, but once you're logged in, then maybe you're going and grabbing a bunch of records from a remote database, and maybe you're manipulating those in some way. It's taking you all the way from beginning to end of the functionality of your application in the browser. All right, so these are the technologies used for testing Angular applications. This is by no means a comprehensive test or list of the tools and technologies that are used. But the most common ones used are Jasmine for the test framework, for the test runner, Karma, and end-to-end testing, Protractor. Karma and Protractor, for them being the primary ones used in testing Angular applications, is they're built by the Angular team, they're made for Angular, and well, they come with they come pre-configured in the Angular CLI. So it's pretty much the easiest thing that you can use. I like some other tools though. So what we're going to be using today, I am going to use Jasmine, and I'll briefly touch on Karma, but I want to show you another tool that I really like using, and I think it makes writing your unit tests a lot easier, Wallaby.js. And we're not covering the end-to-end test frameworks, so maybe for another talk. All right, so let's go through some of these technologies. So Jasmine, is everyone familiar with Jasmine? If you write unit tests for JavaScript, most likely it's in Jasmine. Jasmine is one of the most commonly used ones, although Mocha is pretty common as well. But in the Angular world, King. So it's a behavior-driven development framework that's commonly used in testing JavaScript code. So it allows you to write tests against scenarios. That's why it's called behavior-driven. So like I was mentioning earlier, when you're writing unit tests against your application, typically what you're doing is you write out different requirements for whatever it is that you're testing, and then you write a test against that requirement. So therefore, you have these, first of all, you have describe statements. This is essentially creating a suite of tests. Suite meaning a grouping of tests that you would typically run together. And then an it function is where you're actually defining an individual test. So this should set the selected character property here is the text that we would display for this test. That is one particular requirement for the function. So typically when you're writing Jasmine, you you write it in this type of a fashion. You describe some behavior, and then you write the test for it. Jasmine comes with a number of matchers. These are some of the common ones that I use all the time. And so what a matcher does is it allows you to, when you're writing your test and you're writing whatever it is that you expect that test to do, you use a matcher to show that. I'm gonna go one slide back here and show. So for this little example here, we have a little bit of setup. We execute our function, and then we have this expect statement. So the expect statement is where we take some piece of criteria. In this case, so expect is a function. We pass in an argument of some object, something that's going to have a value, and then we use a matcher. We can chain that matcher onto the onto the return of the expect function. And so in this case, we're saying that whatever the value is of the selected character property on a component, on this particular component, it needs to be the character that we defined above. Okay. All right, so these are a few other matchers that are commonly used, and I give a brief definition. Although technically, I guess an example I'm trying to represent it is not a definition, but does everyone know the difference between double equals and triple equals in the JavaScript world? So, so double equals it has the same value, but it's a little bit more loose in its evaluation. For instance, if you're matching against something that's true, it's a Boolean, and you're saying true to equal 1, that actually would come out as that matches, because 1 is the equivalent of true in the Boolean world. There are different data types, one's a number and one's a Boolean, but this double equals or 2 equal is a little more loose matching, okay? To be is triple equals. Now this goes through data typing as well. So the example that I just gave, expect true to be 1, that would come up false. That does not match, okay? Some of the other ones, to match, this just allows you to use a regular expression in the matcher, and to have been called with. These are for evaluating whether a function was executed.
We have a question in the chat.
Okay.
In Jasmine, is there a way of writing parameterist tests? Also, can you do something similar to quick check / FS check?
You know, I'm not familiar with that, but I will. I'll take a note of that, or I'll take a look at the chat after, and see if I can get you an answer to that.
Okay.
Okay. All right. Thanks, Sam. All right. All right. So that was the what do we call that? That was the test framework. Now let's get into test runners. All right, so karma, like I mentioned earlier, is the most common one used in the Angular world, mainly because it's what the Angular team developed. What a test runner does is, so we talked about Jasmine. That's essentially, I'll call it a language. It's a test framework, but that's what you're writing your tests in. But now you need something to actually execute those tests. So that's where karma comes in. It will gather all of the tests out of the .spec files, which is the typical naming convention for test files in the JavaScript world, especially Angular. So we'll gather up all of those and execute the tests and present you with whatever the result is. Running Karma using that, sorry, we have a question. Yeah. Sure. Yeah. So the question is whether tests can be written using TypeScript, right? And so Jasmine is the framework. It can be written in JavaScript, but it can also be written in TypeScript. I write all of my my Jasmine tests in TypeScript, and we'll see some examples of that in just a little bit. So you're able to take advantage of all the strong typing of TypeScript in the that you're writing. Does that answer your question? Okay. Yeah, we'll see. I'm going to go through a number of examples, and we'll also try and, as a group, write some tests together, and so it'll give you a feel for that. All right, so running Karma with the Angular CLI is easy. If you hadn't already created a project, then you would just do your ngNew to create your project. But then really at that point, a new project with the Angular CLI comes with Karma pre-configured, which is amazing because Karma is not the hardest thing in the world to configure, mainly because we've had seed projects for a long time that have had a configuration file for Karma ready to go, so we can take that and tweak it to do what we need. But if you had to write it from scratch, it's the most intuitive thing in the world. So Angular CLI comes with Karma pre-configured, and as soon as you have your project up and running, you can execute the ngTest command, and that will fire up Karma and execute any test that you have. The default output or reporter that Karma uses is one that looks like this. So you can see it's pretty nice and easy to read. Typically, especially if you have a smaller application, it runs pretty quickly. If you have a larger application, I mean, any testing framework is going to start slowing down. But I find that Karma gets a little slower than some of the others. But that being said, I don't want to knock Karma. It's really good. This is a nice, easy to read report that shows you all of the tests that have passed. In this case, it's all of them. If we had any tests that were failing, this page would look very different. We would see, I probably should have thrown an image of a failing test in here too. Maybe we'll see that in a little bit. But you would see which test failed, and you would get some sort of a response that tells you expected true, received 1, or expected true to be 1, something like that, just going off of the example we were talking about earlier. Okay, so that was Karma. Wallaby. Anyone familiar with Wallaby.js? You're gonna love it. Wallaby's awesome. What IDEs does everyone use for Angular development in here? WebStorm? Okay. Sorry? What? VS Code? Okay. I'm a VS Code guy myself. So WebStorm, VS Code, it works with either one of those. I'm going to show you a little image here that shows you it in action in VS Code, but this same type of output can go on in WebStorm as well as Sublime and a number of other ones. But so the nice thing about Wallaby is that instead of having to run Karma, have that side browser up that shows you all of the output, like Karma also will give its output in the terminal as well. But instead of having to look at all of that, directly in your IDE instantaneously. So as you have a failing test, you get information right there telling you what's going on. This is great when you're writing an application in a test-driven development fashion, because you don't even have to save the file to get these things to run. You just update the code, and it's automatically running in the background for you. Sure. So I use Wallaby with a very large Angular application. Honestly, it takes a little while to start up. Okay. So what I typically do when I open up VS Code and I navigate over to the project that I'm going to be working on, first thing that I do is fire up Wallaby. For the project that we're going to be looking at in a few moments, it'll take seconds. For my main project, it takes a minute or so, but it's only right up front. Okay, so it takes a little bit to start up, and then from that point forward, as you're making these changes, it's not re-executing all of the tests in your entire suite. It's only executing the tests around the area that you're working in. So it's actually able to move really fast. It's running in the background in a Electron shell. So it kind of gets encapsulated off to the side, and I haven't found that it really is all that taxing on my machines. All right, so we'll see a lot more of Wallaby going forward here. Right, mocks and spies, or instead of mocks, I'll call them stubs. I'm sure some of the folks in this room maybe, or in the chat or watching, or maybe going to disagree with me about mocks, because it seems like, as I was mentioning earlier, we have lots of varying definitions of mocks and spies and all of these test double types of technologies in lots of different languages, but especially in JavaScript. But these are a couple of key components to writing your tests. So, according to Wikipedia, mock objects are simulated objects that mimic the behavior real objects in controlled ways. So let's say you have a class that's a service in your Angular application, and you're using that service in a component someplace, and you're writing tests against that component. Now, you don't necessarily want to execute the functions that are in the service, because you can expect that service is being tested on its own, right? So you expect that service is being tested, the functions that you're using from that service are being tested, and in the component that I'm writing tests for now, I'm not going to inject that service. I'm instead going to replace it with mock. So it ends up being a new class that has a very similar structure to the class of the service that you're trying to use. And it gives you control over it. It allows you to include spies on different functions. I'm missing some slides. So I will talk you through spies. So a spy is essentially when you want to, like Homer Simpson here is a spy, you want to keep an eye on some function. So you've mocked this service class. The class has a number of functions on it. You want to make sure not necessarily that those functions are functioning properly. You want to make sure that they're being called, okay? So you create a spy for those functions. And so then you would write, let's say you have a service that has a function that says that's called delete character. And so actually make an HTTP request to your backend, to your server. And it's going to tell the server that we need to delete this particular record from the database. Yeah? You don't want that to actually happen. So instead you create a mock for the service, you create a spy for that function, the delete character function. And then when you're writing the test against area of your component, you use that spy to just say, did the delete character function get called? I don't want you to actually call it. I just want you to tell me, did it get called? So you're spying on it, okay? All right. Let's start digging into the application that we're gonna be looking at some example tests against, and then hopefully writing some tests as well. All right, tour of heroes versus villains. All right, everyone familiar with the Tour of Heroes app? It's something, if you haven't looked at the Tour of Heroes, it's the entry-level app for writing Angular applications. It's something that's up on the Angular.io website. Most of the tutorials that are up there, which are great, by the way, if you haven't gone through the tutorials, I would highly recommend it. It walks you through the Tour of Heroes app. So I've taken the Tour of Heroes, cloned it, and it's the same old Tour of Heroes application, but it's got a twist. First of all, I've added villains, so we get to have some fun. And of course, I've added some unit tests. So the Tour of Heroes there's a few different versions of it floating around. It originated with a project written by John Papa, I believe. And I cloned John Papa's copy of the Tour of Heroes, which had no unit tests. So I went ahead and wrote some tests. All right. So let's get into some of those tests. We'll look at some examples. All right, so we'll go through a few different things that you typically would want to test. One thing that for any application that's written using the router, you're typically going to want to navigate a user around this application. Now you could do that using router link and the templates. Also write tests for. By the way, we're not going to be looking at any tests against the template today. We're focusing in on the TypeScript classes. So in a TypeScript class, you might execute a function like navigate to navigate a user to a new route. So this is what a function that does that might look like. Pretty simple. We're constructing the URL and then executing the router.navigate, the navigate function on the router, and sending them to that location. The test written against it looks like this. Actually a little longer than the function, which isn't necessarily abnormal, but it doesn't take long to write. So like we mentioned earlier, the text in the it statement describes some requirement that we're testing. In this case, that you navigate over to the details page for a given character. So we have a little bit of setup to do. We just finished talking about spies, right? So here's our first look at one. We create a spy on the navigate function of the router object. Okay. So the spy on function is something that comes with Jasmine. Okay. There are other variations on this in other languages. In Mocha, they have something similar. I actually looked up that function earlier today, but now it's slipping my mind. But every testing framework is going to have their own size. But so this again is taking an object that we've mocked. We'll see how that's done later as well. So this is an object that was mocked, and we are putting a SPY on the navigate function, okay? So now we've got this variable representing the SPY that we can evaluate later on. We have a little bit more setup to do because if you notice here, the goToDetails function receives an argument. It's a character, and it's strongly typed. So, so we need to create a new character, which this is all written in TypeScript here. So this is your first kind of look at this. If I had created this object as just just some sort of an empty object or a regular object rather than being part of the character class, then we would have some typing issues in here. But so we create this character object and assign it an ID because the route is being generated based on the ID. Or the link, the URL is. And then we pass that character into the goToDetail function. At that point, we just need to say, what is it that we expected to happen when we executed this?
Hey, Keith.
Yeah.
We have some questions in the chat. So
Okay.
the first one from Alexander Torres is, does anybody know how to bubble up tests in a DevOps continuous integration pipe? I am using Team Foundation Server. Do you know the answer?
So in Team Foundation Server, so I have actually done a little bit of testing with Team Foundation Server, and there was a plugin that we installed. Now this wasn't in Angular, but I believe there is an Angular plugin that could be installed in Team Foundation Server as well to look for those at the results and fail a build or whatever when necessary. So the Team Foundation Server is the code repository, but it's integrating with a lot of other build frameworks and things like that. So yeah, there are plugins, I believe, to do that, but I'd have to get back to you about which ones.
Okay, the second one, there's two more. Yes, one more now. Okay, is this using the router testing module? That's the slide you're on now.
Yeah, no, this one is not. The router testing module was imported. Real quick. Let's see here. This is. Let me bring up the code. We'll look at the bigger one. Okay, so I think it's going to be in the characters component. All right, so the router testing module is being imported into the spec file, and then in the test bed where we are configuring the test module being imported there. But let me flip back over to the slides, and guys, we'll get into that whole configuration a little bit more in a moment, so some of that makes sense. I don't want to derail you too much on that. So we did import the router test module mainly so that the suite of tests don't fail because of the fact that the router is being injected into this class. But what I've done here, creating the SPY on the navigate function of the router, this is not utilizing the router testing module. You can do other things using some of the features of the router testing module to do this as well, but I find this to be a much simpler way of figuring out whether or not the appropriate navigation actually happens. Okay, so then just finishing this off, our expect statements, we pass in our SPY. So at this point, again, because of the fact that we ran this earlier here, I did it, I could have actually written this as just SPY rather than router.navigate, but the navigate function on the router does act as a SPY because of the execution of this line here. So the navigate function is to be called with. So this means this is a function that we're spying on. We're checking to see whether or not it was executed, and then we're doing to be called with. So we get to actually dictate what the arguments were for that function that was called. So we just pass in what we expect to be. Okay. And feel free to interrupt me with questions as well if anything comes up. All right. Have I lost you? So it's what allows us to just check and see whether or not it's been executed. This type of a matcher. Yeah, that would have worked too. I think actually in the original version of the, I think I just wrote this a little differently. Let's see here. Go to, this is actually a different. Go to detail, there we go. There's the correct one. Okay, so, and the test is not there. Let's throw this in there real quick. I've got a bunch of setup that I'm going to have to do. But so I could have written it. Let me just show you what it would have, what it could have looked like. This function actually puts a spy on the navigate function on that object as well. But because of the fact that I created this spy function or the spy variable with it, I could have just done it like this as well. You can really do it either way. All right. Okay. Asynchronous functionality is something that we test quite a bit. And there's a couple of helper methods that Angular provides that assist with this, called fake async and tick. Tick is something that you use in conjunction with fake async, and it's essentially what allows you to take an asynchronous function and take control of the flow of it. Right, so here's an example of an asynchronous function. The save function here is calling a method on a service that we have. So you can imagine what this is probably doing. It's executing some HTTP request, sending a request up to the server, asking you to save this new character. And in this case, it's returning a promise. And then, so the promise is then resolved when the response to that request comes back, and then we do something with the data that's returned. So the way that we would test this, we take advantage of fake async and tick. So fake async wraps around the rest of the test function there. And it means that everything inside of here you're assuming is running asynchronously. So then at this point, what we're able to do is we create a spy on that service function again. And this is actually adding on to the capabilities of the spy. I'll point out we're actually able to dictate what the return value is going to be. Again, the whole purpose for creating spies is to take control of it. So that in a test that says when this function does this thing, then I expect these other things to be true. Right? So, so we create the spy on the save function for the character service, and it's going to return a promise that's in this case, we're going to say that this is a failed request. So the promise is going to reject, which is essentially simulating that the request failed for some reason. Okay. Yes. Question. Between promises and observables. Okay. Sure. Well, I'll take the last part of your question first. So question, when would you write a test against an observable, and when would you write one against a promise? So the simple answer to that is the function that I'm testing is already set up to return a promise. So that's why in this case I'm handling everything as a promise here. Now the save function could have returned an observable as well. So the first part of the question was when would you use a promise as opposed to an observable, or vice versa, right? It's really, for all intents and purposes, it's personal preference. In the AngularJS world, we use promises all over the place. And in the Angular world, Angular 2, 4, 5, we've kind of switched over to using observables more. The difference between a promise and an observable is a promise only will return one value. It's resolved once, and then its usefulness is really no more. With an observable, you can return multiple values. It's something that you can subscribe to, and we'll see some of this too. We'll see some tests written against functions that are returning observables as well. But this function that's returning an observable, that observable can be resolved multiple times to return different values. People talk about them typically as being data streams. Okay. Does that answer your question? We could go a lot deeper into observables. It's if you missed Reggie's RxJS talk here at ngHouston a little while back, I would recommend it. RxJS is the technology used by Angular to implement observables in Angular. He gave a very good talk about it. So I'd go and check that out, and that'll tell you a lot more about observables. All right, continuing on here. So we execute the function. Again, this is asynchronous in nature. So we have a promise that needs to be resolved, and the promise, typically there's a bit of a delay, and then this promise is resolved, especially when you're talking about an HTTP request. So because of the fact that we're using this fake async wrapper around this, if we were to remove the tick function from here, when we got down to our expect statement, it would tell us that error is undefined because the promise never resolved. The time didn't lapse to allow that promise to resolve. The tick function allows us to go ahead and move forward. It's essentially turning this asynchronous functionality into a synchronous way of writing the test. Okay, so we take control of that data flow. We execute the tick function that allows that period of time to pass, meaning that the rest of this function, actually in this case we're catching an error because we're rejecting. And so then at that point we are able to evaluate our expect and expect that the point was passed on and set to the error property as we've set here. All right. All right, another scenario is event emitting. So, you know, Angular components have inputs and outputs, right? Outputs typically are event emitters. A that is utilizing your component, they're able to subscribe to an output that your component has, and and that output will emit values occasionally. So here's an example of a function that ends up emitting a value. And here's the test that you would write against it. So this is an example of how you could write a test against an observable. Because an event emitter is a type of observable that you can subscribe to. So in this case, we are, so again, when you execute the go back function, you pass in a character, and then the close event emitter emits that saved character. Okay, so in this case, we are we're going to subscribe to that event emitter. This is an observable. So we subscribe. In the subscribe function, you give it essentially a callback, and that will pass in the value, the result of that event emission, I guess you can call it, and then we can actually include an expect statement right here inside of the subscribe. So we can expect that the result of the event emitter is the expected value, which is the character. And it, because of the fact that when we actually execute the go back function, we pass in the expected value, the character. Okay. Now this one is a little awkward, right? Because we're actually putting our expect statement before we've actually executed the function that we're testing. So sometimes things get a little bit out of order, but there are actually other options for how we can write these as well. I could have used the fake async here as well. This is really an example of a time when I chose not to use fake async. Fake async is not the end-all be-all for writing tests against an asynchronous function. It can be very helpful. I think I'm going to go back to the previous one real quick. The way that we see this functionality just kind of stepping its way down. Okay, we set up our SPI. Okay, now we execute our function. We allow the time to pass, and then we expect some value. This, to me, reads a lot better. But this is also perfectly valid way of testing an asynchronous functionality. All right, so sometimes you use the global window objects. So like, let's say you want to be able to navigate the user back using the back function of the browser. You would use the global window object for that. Or maybe you need to store an authentication token in local storage or something like that. These are global variables that you sometimes, or global objects, I should say, that you sometimes need to write tests against to make sure that they are being used properly. So an example of a function that might do this is actually the same function that we were just looking at a test for as well, just another part of it. So the go back function, as we saw before, it's let's see, it first emitted a value that was the character that's being saved, and then the next part of it is execute the back function on the window global object. So the way that we would test this is by using SPIs. We can take that object. In this case, the back function actually exists on the history property of window. And create a SPI here on that back function for the window history object. Now we've got our SPY. So this shows the other way that we were talking about earlier of using the onSPY, where we have the variable, we get our setup in here, just setting navigated equals to true because that was a contingency up here. Then we execute our function and we just expect that the SPY has been called. That tells us enough. That tells us that the back function was executed. We are using the window history object correctly. Okay. HTTP is another big one to test. And we'll take a look at how to write a test against the function that we see here that's using HTTP, which is doing HTTP requests in Angular. And then I'll show you a variation on this that would be for the HTTP client, which is a pretty recent addition to Angular. Right, so in this function, this is getting characters. It's the HTTP service from Angular, and it is sending a GET request to a particular URL. Now the GET function on HTTP by default returns an observable, but I'm going ahead and actually changing it over to a promise. This is kind of what I was getting at earlier. I mean, sometimes it's just personal preference. A lot of folks feel more comfortable using promises because that's what they did in AngularJS. So you can easily do that with RxJS as well, change an observable into a promise. And then we do something with the response. All right. So let's take a look at what the test for this looks like. Tests against HTTP are a little bit harder to read, in my opinion, especially with just the fact that you have to use. It's got a couple of utilities that it gives you to work with HTTP. Last connection, it's essentially mocking the HTTP requests that you would be sending to the server, and allows you to control what the response is and so on and so forth. So, but to write that, it's a little ugly. So we're using the fake async function here again, and that again just kind of allows us to get a little more control over the flow of data. We execute the get characters function, which is what we're testing. And because of the fact that it was returning an observable, that's where we can do a .then. And this is where we can grab hold of what the result was. And we can then write some expectations against that. Now, before we tick, we do need to go ahead and set up what the response is. So that's where last connection comes into play. And we mock the response using the mock respond function on last connection. So here we basically just say that this is returning an array of the characters that we defined up above. Once we have all of that set up, we are ready to go ahead and make our expectations. So we go ahead and execute the function that allows that period of time to pass. So now the function has fully executed, and we can check and see what happened. So there's a number of things that you typically would want to test on an HTTP request, such as where was the request sent to? So here, last connection keeps tabs on that. It has a property on it called request that has a lot of information about that request, including the URL. And I'm using the toMatcher, which, if you recall, allows you to use a regular expression to define what you're expecting here. So this regex statement is basically saying that we expect a request to have been sent to app/characters. That's the URL. Or path on the URL, I guess. We can take the result function and make sure that it actually gave us back what we expected. I'm expecting it to have returned in an array. So the length should be 2, and that the 2 objects are in the correct place in the array. The result 0 and 1. You have another question? Right. Okay, so let's that function should be in here. Let's go take a look at that and see what happens when we play with this. Okay. You guys see this okay? We need to zoom in at all? Good.
Can you make that a little bit bigger?
A little bigger? All right, for the viewing audience.
That looks great. Thank you.
Good?
Yep.
Okay. No problem. Okay, so let's see here. This is the function. Or the test. And the function that we are actually testing, let's see here, get characters. There we go. Okay. So if we comment out that tick function, we'll see that our tests start failing. Cannot read property length of undefined. So because of the fact that we are using fake async, it turns this into actually really a synchronous bit of functionality here. And so we need to actually dictate what the flow is. So in this case, yeah, we are defining what the response is going to be here. But because of the fact that this is all dependent on a promise being resolved, hence the then function, we need the promise that's being returned from this function to be resolved before the result function, the result variable is actually populated with anything. If I don't execute the tick function, part of this never gets executed. So result never gets a value, and it just stays as it is up here, which is undefined.
Hey, Keith, the people in the chat want to know the question that's being answered.
The question, sorry about that. The question that was asked was, why is the tick function needed in this scenario? Am I correct? Yeah. So, the fact that I think that what was causing the confusion is the fact that we were defining what the response was going to be. So if we're defining what that response was, then why do we even need to run the tick function? And it has everything to do, again, with the fact that this is all based on a promise. We need the tick function to push forward the timeline, allowing the promise to be resolved, which in turn populates the result variable. So if I put that back in here, it's going to rerun the test here, and that allows it to pass. Last connection is, so it's actually a mock connection. There are a few things that we need to import from, how did I do that? There are a few things that we have to import from the HTTP testing suite that assist us with this. Mock backend, mock connection.
Hey, Keith, don't forget to repeat the question.
Yeah, thanks. I think I was doing better with that in the beginning, but all of a sudden I guess I'm forgetting.
You're doing great.
Thanks, Sam. So the question was, we getting the last connection from? So yeah, last connection is something that that we define, or I've defined up at the top of the entire suite for this test file, the spec file. It is a mock connection, which we imported Angular HTTP testing module. We then, we have to set things up a little bit. So we are, this is getting a little bit ahead of, I'm showing the configuration of how you set things up here, but here's where we're actually taking our mocks and telling the injector what to replace with our mocks. And so, so in this case, we are actually replacing the backend that we're connecting to with a mock backend, and we're replacing the requests with some of the base request options. And what that allows us to do is then, using the connections on our mock backend and subscribing to it, we are able to always, whenever we are executing an HTTP request or a function that is executing an HTTP request, we are able to, because we're subscribing to the connections on the mock backend, we are able to populate the last connection and then use that going forward. It will then house all of the information about the request that was sent.
We have a question in the chat.
Okay, go for it.
Are there any techniques that you can think of to split the logic from the outside world so we don't need to rely so much on test doubles? Test doubles as in stubs, mocks, and spies.
I don't know why you'd want to do that, really. So using test doubles or mocks, spies, all of that, it's something that I think it might turn some people off in the beginning because it takes a little bit of time to get used to it and fully appreciate what it's actually doing for you. But you got to keep in mind that the use of test doubles, it's really allowing you to focus in on a particular area of your application and test that that small area is working properly. Yeah, it allows you to ignore other things that might influence the area that you're testing, because if you have too many areas of influence, you're setting yourself up for failure. You've got too much complexity in these tests, and you can assume also, like I mentioned earlier, you can assume that the areas that you're mocking out, they've got tests against them too, right? So every small area of your application should be tested in as much in isolation as you can. And using test doubles, that's what allows you to do that. All right. Okay. No problem. Whoever asked that question, if that did not convince you, feel free to reach out to me after. We can discuss it more, or I can try and provide you with more information. Maybe there's something that you're referring to there that I'm missing as well. So yeah, let me know if you want to continue that discussion. All right, and I think I covered your question. All right. Great. Okay, back in here. I'm looking at the time here. I'm fearing we're not going to get to our TDD here, so that may end up being a separate presentation, which is good because I would actually like to put a lot more into TDD than what I was going to be able to do in a short period of time here. So another entire test-driven development will be good. Okay, but I've got a little bit more in the examples to go over here. So, all right, so this was an example of writing a test using the HTTP service. That again is really the old way of doing HTTP requests in Angular. As of a recent version, 4.3, I think, but I could be wrong. Maybe someone in the chat can correct me on that. But as of a relatively recent version, they introduced the HTTP client. Has a lot more, it's a lot nicer to work with. We're going to take a look at some at a variation on this test that shows you that you still have a lot that you need to write, but it's a little cleaner. Let me switch over to that now. So, I think that was one line of code less. So it wasn't a substantial reduction in the amount of code that we need to write to test this. But in my opinion, this is a bit cleaner. Let's see. So it has a nice flow to it. So up at the top, we're doing all the same setup that we did before, getting the data ready that we're ultimately expecting the response to be, and then we go ahead and we execute the get characters function, and we subscribe to the response. This is going to be returning an observable in this case. All right, and it could return a promise though. This could be a dot then, and be essentially the same other than that. But we're doing this one as an observable. So this then the subscribing here then allows us to just populate some information into our result variable that we set up here, so that we can write some expect statements against it. Then, much like we had last connection in the previous one, now we have HTTP mock. And HTTP mock, I can't show you this one in code because I'll preface this with or give a disclaimer here as well. The previous one, I tested that one actually worked properly. I couldn't install HTTP clients on Tour of Heroes though, because it's using the in-memory API that's used for putting together a lot of these example applications, and the in-memory API is not yet HTTP client compatible. I haven't tested this yet. I believe it'll work though. So it gives us the HTTP mock. That's another utility that is provided by Angular, and here we can take that HTTP mock and we can expect that it was executed one time. There was one request that went out, and it went to this location. Then we can expect that. That also returned a variable representing the request. We can then use that request forward and write some more expectations against it. A common one might be, what was the method, the HTTP method that was used, or actually what's it called? Method action, HTTP action. What's a get, post, put, verb? There we go. So what was the verb that was used? So, well, it calls it a method here. I'm going to call it a method. So what was the method used on the request? It was a get. So we can write an expectation for that. We can flush the request, which means this is where we actually want that request to go ahead and give a response. One key difference between HTTP and HTTP client is that it just by default expects that you're returning JSON. And so when you subscribe to the execution of the get function on the HTTP client service, it just by default, it's returning you whatever the JSON response was. So we can just do flush and pass it in the object that we plan on having it respond with. In this case, it's an array. And then we write our expect statements against it. The length was 2, all the same stuff from before. But this is just a little cleaner, a little easier. Ultimately, it's doing basically the same thing here, but this last connection and mock respond honestly, there's not much to it. You get used to it, but it always throws me off. It muddies up everything. So we're writing tests against the HTTP client. They've made it a lot cleaner, I think, and a lot easier to reason about. Okay, well, it's supposed to be TDD time, but like I said, we've got 8 minutes here, I think. So I think we're gonna push that to another presentation, which I'll try and get on the calendar again sometime soon here. What I wanted to do here, which we'll start with this in the next one. We're going to implement a feature where the villains attack the heroes. All right. So essentially what we want to do is, again, this is just kind of a preview of what the next presentation that I'll give will be. We want to write a function to implement these requirements. Well, actually, I'm sorry. These are not requirements. This is really the way that I would go about doing test-driven development. So we'd have a set of requirements, and what we would do is create this kind of shell of a function, and then start writing all of the tests that we want to actually build out for testing out this function. And each one of those tests will represent different requirements that the function is supposed to complete. And the process really is, in test-driven development, you write a test that fails the test. So you write this test, it's going to initially come up red because it says that you were supposed to execute this HTTP request. But because I started off with this empty shell of a function, it's not actually doing anything yet. It's just, delete character. It's not doing anything in it. But I've written this test that says that it's supposed to send an HTTP request to the URL that's going to delete. Okay, so it's failing in the beginning. Then I write the minimal amount of that function to make the test pass. Then I move on to my next test. I write that test, it fails. Maybe it's when you, once that deletion has completed, now we need to remove that character from the set of characters that we have locally, okay? So I write a test that says that character shouldn't be there anymore. It's gonna fail because I haven't done that yet. Then I go back to my function, I add that bit of functionality into it, now my test passes. And you just kind of iterate on this thing. You write a test, it fails, you write the minimal amount of code that you can to make that test pass. And when you're done, you end up with a function that is fully tested, and you have all of your requirements documented in those tests. We'll get deeper into that in another session soon. All right, let's code. We'll do that next time. All right, any questions, comments, concerns? Got one, yep. Sure. Mm-hmm. So the question was, an argument against TDD sometimes is that you write a function, you write an application with a bunch of tests based on the current understanding of the requirements, and then maybe your client changes their mind and you have to change things around. So you might say that it creates more work for you and having to deal with all the tests, right? So that's not really, I would say, an argument against TDD. It's an argument against testing at all, right? So whether you're doing TDD or not, if you have tests against a application that ultimately is going to get stripped out or rewritten, something like that, yeah, you're increasing your workload a little bit. But the thing is the majority of your application is most likely going to not get thrown out and not fully rehauled, right? So you'll build out this application, you'll spend a few months on it, you'll write lots of tests. And then you present it to your client. Hopefully you've presented things to your client a few times in between the beginning and the end of the 3 months there. So you get some feedback throughout. But you come across some feature that they say, in the way that I expected. Well, that probably means there's a small portion of your application that's going to get thrown out and rewritten. And yeah, you're going to have to rewrite some of those tests. But chances are also that area is not really getting fully thrown out either. It's more that it's getting tweaked. And having those tests in place, it also will tell you whether you have updated things appropriately to still get the same end result, or whatever the current set of requirements are. So in my mind, what that type of an argument really is more about, though, is test coverage. Like, some folks argue that you should go for 100% test coverage. I am not one who subscribes to that. I like having a high test coverage. Like the main application that I'm working on these days, I try and stay around 80% or above 80% test coverage. I test all the components, all the services, all the HTTP. We're using NGRX, so writing tests against our selectors, some of the reducers, effects. All of this stuff can have tests against it. But there are times, though, when you don't need tests. Let me bring the code back up. Let's see if I can find a good example of this. I think character details has an example. No, maybe the character search component. Man, I am good. I write lots of tests. This is crazy.
I would like to know. Oh, let me pull it back up.
Give me 1 second, Sam.
Okay.
So, okay, this is a prime example of a function that I really don't think needs any test written against it. It's very simple. All you're doing is setting a couple of properties. Now, maybe it wouldn't hurt, because this also is probably something that chances are the requirements that you're fulfilling with these 2 lines of code, they're probably not going to change. And if you're doing TDD, one of the reasons why I like to do TDD is it helps me think through what a function is supposed to do. This one's so simple that this argument doesn't really fly, but I'll take a function and I'll just think through, it needs to do this, and then this, and then this, and writing out all of those tests right off the bat, or at least writing the it statements, the text in those its, helps me formulate things in my mind to be able to actually piece together the function a little better. But we don't need to write tests against everything. Something as simple as this, I think this is doing what you expect it to do. It's something more like this, where you have some sort of logic that's happening in here. You have if statements. You have different conditions that need to be evaluated. Those are the things that need to have tests written against them, and it'll help keep your code quality up. I'm not sure if I really answered your question or just railroaded it, but yeah, okay. Question in the chat?
Yeah, sorry about that. Sean wants to know, can you get coverage from the test order?
Can you get coverage from the test order?
Runner.
Test runner, yes. So we've been looking at Wallaby.js for the most part here. And it does have a test coverage. First of all, all of these indicators along here, these are giving you in the IDE an idea of what your test coverage is. If something has no test written against it, you get these little white squares. If something has a passing test written against it, you get green squares. Something's failing, you have red squares. So this will give you an idea, at least of the area of the application that you're looking at, what your test coverage is. But overall test coverage for the entire application, Wallaby.js does create a test coverage report as well. But to be honest with you, I'm still somewhat new to Wallaby.js, and I could not tell you how to generate that report. So I still use Karma for generating test coverage reports. And there are...
hey Keith, what plugin is that?
What's that?
What plugin was that?
What plugin? I just switched over to a different project that I'm working on. So we're in Visual Studio Code. This just happens to be one that has a Karma reporter installed. Maybe that's the plugin you're talking about, Sam.
It's from Sean.
Oh, gotcha. So I am using the Karma Coverage Istanbul reporter. And so whenever I run my tests through Karma, which I do, even though I'm using Wallaby, I've got Karma running a lot of times too. I use Karma on our continuous integration server. So whenever I'm committing code, test runner that will execute all of my my code and generate a code coverage report for me. And I just brought up report here. So it'll look something like this. So here you have all of the different sections of your application and an idea of what your code coverage looks like in each one of those areas. If you were to ask me for a definition of all of these different categories, I'm probably not going to be able to help you all that well. But statements, wow, I just resorted that as well. Let me see if I can refresh this page. Statements and lines tend to be two of the main areas of focus from what I've found about code coverage reports. Reason why I say I can't really give you a great definition of them is it seems to me like some of these things don't mean exactly what you tend to think of when it comes to lines and statements and branches. If anyone else who is attending has a good definition of these, please add it to the chat or tweet it out. It'd be helpful. We have another question. So Karma comes with a lot of reporters. So you can find the one that works best for you. Let me just fire up Karma real quick. The question was for generating a report. You're talking about the report about the test, not the test coverage, right? Okay. So for generating a report that results of your tests, what's a good reporter to use? So I think the Karma Jasmine HTML reporter is pretty solid. It's what I had an image of earlier. So this is running through the test suite right now. executing the tests, and in just a moment, we should see the report up there. Now, the report that we're about to see is not one that is actually written to disk. Like, I don't get an HTML file out of it that's, that I can, put up on a Jenkins server or someplace else where people would be able to see it. However, so that's when I'm just running it constantly, running constantly. Show me the report, but not write it to disk. But you can, and I believe it's using the Jasmine HTML reporter. You can also have it export an HTML file that does that. Yeah, I'll get back to you exactly about how that's being done. We are on my project, we are using this reporter to generate an HTML file that is displayed for other developers and managers to look at, to see how we're doing. So so you can use this reporter to. Wow, I think I just ran these tests against the wrong project. That's why it's taking so long. It's a lot more tests here, but yeah, you can generate an HTML file out of this report and save it someplace. But there are other options as well. If you go to the Karma websites, I believe they will link you to a place where you can find lots of plugins, and a lot of those plugins are reporters. So yeah, I did. What you see here is what we then take for my company and put it up on a server for everyone else to see what we're doing. It's long. Got a lot going on. All right. Any more questions? Anything on the chat, Sam?
Nope, looking good.
All right, guys. Thanks everyone for joining. Like we've mentioned a couple of times at this point, I didn't quite get into everything that I wanted to. I wanted to get into TDD, but I think we had a lot of good discussion. Got a lot of good content out there. So I think this is an acceptable loss, and we'll. I'll try and get on the schedule again sometime soon, and we'll get a little deeper than I was even planning on today into test-driven developments and how that's done and what all the benefits are. Thanks, everyone.
Oh, he left. Thank you, everybody, for joining.